In this video, we're going to use unit rates to solve application problems. Represent the following scenarios as unit rates in the indicated ways, then use this information to answer the corresponding questions. So we're given that Stephanie can walk 5 miles in 2 hours. Use this information to fill in the chart below and use decimals when needed. So notice for our chart, we have the first row gives us amounts for hours, 1 hour, 2 hour, 3 hours, etc. And the miles is blank. An assumption that we're making is she can walk 5 miles in 2 hours, and that's a constant rate that she can walk no matter how many miles she's walking. Now, of course, she probably can't do this for 24 hours, maybe not even 7, but we're going to assume that she can. So, in 2 hours, she can walk 5 miles. So that's one piece of information we can fill in immediately. So how are we going to find the other values? So we're going to use this idea that she can walk at this constant rate no matter how many hours it is. So we're going to use doubling and halving. This is very useful. So if she walked for double amount the time, 4 hours, 2 times the amount of time, she would walk double the amount of miles, which is 10 miles. Okay. Another 2 hours after the 4 hours would be 6 hours, so that would be another 5 miles for a total of 15 miles. So using doubling, we've filled in 2 more spots. And now let's use halving to fill in the other spots. And this one, where hours is 1, this is our unit rate. This is a really useful value to find. So since 1 hour is half of 2 hours, the number of miles she can walk in an hour is half the amount of miles she walked in 2. So we would divide 5 by 2. I'm just going to write 5 over 2, which is 2.5 miles in 1 hour. Okay, so notice how this rate, 5 miles over 2 hours, corresponds to this value. Okay. So if she can go 2.5 miles per hour, to find the other values, we can continue to add on 2.5 miles from the previous amount. So 2.5 plus 2.5 is 5, so that corresponds. 5 plus 2.5 is 7.5. Another 2.5 is 10, so that checks our work. Another 2.5 is 12.5. And another 2.5 is 15, so that corresponds with our work as well. So now we're asked, what is Stephanie's unit rate of speed in miles per hour? And I really want you to take notice that it says miles per hour. That's one we typically find, but we're also going to find hours per mile later. And I want to make sure that you know that when we have a rate, the first value refers to the numerator, the second value refers to the denominator. And since it's asking for a unit rate, we want a denominator of 1 or a fraction. So, or maybe a fraction or a denominator of 1, either or. So here we know that it's 5 miles in 2 hours. Okay. So we can think of this as 5 halves miles, okay, per hour. So this is what I meant by the fraction part. This fraction doesn't have a denominator of 1. But since I'm putting the 5 halves in the miles portion, it's 5 halves per 1 hour. So notice the hour is no longer referring to 2 hours. That 2 has gone to the miles portion. Okay, this corresponds to 5 divided by 2 is 2.5 miles per hour. And we can determine this from the table by looking at the first column. And this is because the first column in the table tells us 1 hour, so we can see the corresponding amount of miles. Next, we're asked, using the unit rate of miles per hour, how far will Stephanie walk in 8 hours? Also write the corresponding proportion. So we could continue on with the table, and it's good for you to look at patterns, but let's use the unit rate. Okay, and we could use it in fraction or decimal form. I'm going to use it in fraction form. We'll use decimal form for the next one. Okay, so 5/2, and I'm going to put my units here because miles per hours, we'll put per hour, times 8 hours. Okay. And the reason I know that this is correct is because notice the hours line up and they're going to cancel, and I'll be left with miles. Okay, so that's, since we have our unit rate of miles per hour, I knew it was miles over hours. I was given hours, so when I multiply by hours, these hours cancel out and leave us with miles. So we have 5 times 8/2 miles, and that's 40/2, which is 20 miles. So our corresponding proportion, I'm going to write this over here. Let me put it in green. So we have 5 miles over 2 hours corresponds to 20 miles over 8 hours. So notice that the multiplicative factor is 4. Okay, so 8 hours is 4 times 2 hours. So looking at the table, well, we don't have 8 hours, but 8 would be 4 times 2. And the 20 miles is 4 times the 5 hours. Let's look at the next one. Using the unit rate of miles per hour, how far will Stephanie walk in 3.7 hours? So let's use the decimal form. So 2.5 miles over hours times 3.75 hours. Again, I'm noticing the hours will cancel. So we have 2.5 times 3.75, and our units will be miles, so that's all lining up how we want. Multiply, and we get 9.375. So 9.375 miles. So in 3.75 or 3 1/4 hours, she could walk 9.375 miles. Okay, and notice 3.75, that's between 3 and 4, so that the miles should be between 7.5 and 10, which it is. Let's look at the next one. Now we're going to look at this another way to solve other types of problems. So what is Stephanie's unit rate of hours per mile? So we were told that she could go 5 miles in 2 hours. So to write a unit rate of hours per mile, our hours goes in the numerator and our miles goes in the denominator. And again, we can think of this as 2/5 hours. Okay, so it's like we're taking away the 5 from the miles and thinking of it as a fraction of hours to make this per 1 mile. Or equivalently, this is 0.5 hours per mile. Okay, so try to think about what this rate is referring to. So before we knew that she could go 2.5 miles in an hour. Now this is telling us how long it will take her to go 1 mile. So 0.4 hours is a little bit less than half an hour to walk a mile. Using the unit rate of hours per mile, we want to see how long will it take Stephanie to walk 20 miles. And again, Stephanie does not get tired. Okay. So I'm going to use the 0.4 hours over miles times, we want to know, 20 miles. I like that my units are lining up where one's in a denominator and one's in the numerator. That means I'm using the correct unit. I mean, they told us which one to use, but in the future you don't always know, so you have to set it up yourself. So 0.4 times 20 is 8. So it takes her 8 hours to walk 20 miles. Let's write the corresponding proportion. So we had 2 hours to 5 miles is to 8 hours and 20 miles. Okay. So notice the multiplicative factor between these two equivalent ratios is 4. 2 times 4 is 8. 5 times 4 is 20. Let's look at the last one. Using the unit rate of hours per mile, we want how long will it take Stephanie to walk 26.2 miles. Okay, so that's a marathon, but at least she's walking. Okay, so we're going to use 0.4 hours per mile times 26.2 miles. Noticing the miles cancel. Multiplying, we have 0.4 times 26.2, 10.48, and our units are hours. So if she walked at a constant rate of 5 miles in 2 hours, or 2.5 miles per hour, it would take her 10.4 hours to walk a marathon. Okay? And our proportion would be 2 hours is to 5 miles as 10.48 hours is to 26.2 miles. Okay, this has a constant factor. We could find it by dividing, so 26.2 divided by 5. So this is 5.24 times as large as 5, and 10.48 is 5.24 times as large as 2 hours. So that's the idea behind being proportional, is that two ratios are equal, and there's that factor that you can multiply one fraction by, to ratio by, in the numerator and denominator to get the other.